over some of what you will see in Chapter 5 during our presentation of Chapter 4, just because I think it goes a little bit better in Chapter 4 stuff. But basically what we're talking about in Chapter 5 is how one atom bonds with another. And we didn't really focus on that last time, but we will now. Atoms and bonding. Now, in order to understand atoms and bonding, we need to have a good foundation in some of the things that we studied in Chapter 4. One of the things is valence electrons. Valence electrons. This is a super important concept that we'll need to understand. Side by side with valence electrons is something called electron dot formulas or electron dot diagrams. And electron dot diagrams are super simple once you understand them. And basically it goes something like this. Let me just find my periodic table. Okay. Valence electrons. Who remembers what a valence electron is? Tyler. Meshi. Good. Good. So every atom has a shell or an orbit where the electrons are orbiting. There are, in the small elements, there is a shell that is called the 1s shell. Hydrogen has 1 electron in that shell. Helium has 2. So the electron dot diagram and valence electron numbers for hydrogen and helium are 1 and 2. So helium has 2 electrons in the outer shell. Hydrogen has 1. Let's do another example. Neve. Magnesium. How many electrons, valence electrons, does magnesium have? Look in your periodic table. Yeah, Tyler. Okay. How did you know that it has 2, Tyler? Cool, sorry. How did you know? Yeah, it's in group 2A. So if it's in group 2A, the number of outer shell electrons is 2, and we would draw its electron dot formula, Mg with a 2 around it, like that. Now, does that mean it has 2 total electrons? No. It has 12. Its atomic number is 12, so it has 12 total, but only 2 in the outer shell. How about phosphorus? Phosphorus. How many valence electrons does that have? Look at your periodic table. Iris. 5. And you knew that because it's in group what? 5A. So 5A. And here's the electron dot diagram. 1, 2, 3, 4. You draw it in the quadrants, and one more in the beginning quadrant there. So we've just drawn the valence electrons for phosphorus. How many total electrons does phosphorus have, Bobby? How many does it have? Iris? 15. Good. So its atomic number is 15. Okay. So let's do one more. Chlorine. What group is chlorine in? Kenda. What group is chlorine in? Anybody? Yeah, Holden. 7A. How many valence electrons does chlorine have? Yes. Good. So we're going to draw 1 in this quadrant, 2, 3, 4, 5, 6, 7. How many valence electrons does chlorine want to have now? That is the question. It wants to have how many? Yes. Abby. It wants to have a full outer shell, and it's left over with 1 right there. Okay? So there's 1 spot for an electron. Let me draw that in color so it shows up real well. That's important. So chlorine kind of feels like it is deficient in electrons, and there's an extra spot right there for an electron. This is super important. What is the ion number for chlorine? Cl, remember the ion numbers, up here in the upper right-hand corner. Do they have a charge or no charge? They have a negative charge, and chlorine is negative what? Negative 1. Good. So chlorine's ion number is negative 1. Guess where that comes from? I didn't explain where it comes from in the last chapter, but here's where it is. Chlorine is negative 1 because it has an extra spot for an electron to dock in there. Okay? Now that becomes super important with bonding, and here's why. Let's look at the element sodium. Na. Na. What is sodium's ion number? What is sodium's ion number? Grace. Make sure you have your periodic tables out. Who knows? Periodic tables. Meshi. Ion number for Na. Not just 1, but plus 1. Good. So that plus 1, does it mean that sodium is a giver or a taker? Giver or taker? Yes. Giver. How many does it give? 1. So here we have an element that gives 1 electron. Here we have an element that takes 1 electron. That's a good match. A very good match, because here's how it works. First of all, let's draw the electron dot formula for sodium. It's in group what? What group is it in? Max, what group is it in? Okay, group 1A. Max, how many valence electrons does it have therefore? 1. I'm going to draw the 1 right here. Then, and this is an Na, sorry. So there's its 1 electron in the outer shell for its electron dot formula, or dot diagram. Chlorine now, remember, it has how many outer shell electrons does it have? How many? 7. So here they go. 1, 2, 3, 4, 5, 6, and 7. So guess what? When these two combine, sodium will actually donate one of its electrons to chlorine and let it borrow it for short micro periods of time. So there it is. It's occupying that spot. So this is called an electron donation. Write that down, donation. When two or more elements donate electrons, that is called ionic bonding. And what happens is that the chlorine becomes somewhat negative and the sodium becomes somewhat positive. Somewhat means +1 and -1 to quantify it. Okay? So ionic bonding is when electrons are donated and accepted. That's one of the 2 types of bonding that we're going to focus on for Chapter 5 and how it works. Okay? Let's try another one. Let's try magnesium, and we're going to combine that with chlorine. Actually, let's combine it with oxygen. That's the simpler one. So here we go. What's magnesium's ion number? +2. Good. What's oxygen's ion number? -2. Very good. So these two, remember our cross and drop? Okay? Remember the cross and drop. So what this means in terms of electron dot formulas is Mg, what group is it in? +2. So it's got 2 electrons here that it's going to eventually donate. And oxygen, what group is it in? What group? 1A, 2A, 3A, 4A, 5A, 6A. Yes. 6A. Very good. So here they come. 1, 2, 3, 4, 5, 6. Well, guess what? Oxygen is deficient 2, and magnesium has 2 extras. So what's going to happen is that the magnesium is going to donate 1 and 2 of its electrons to oxygen. And those electrons are going to spend most of their time over here next to the oxygen, making it -2. Magnesium, left lacking in 2 electrons, is going to have 2 more protons overall than it does leftover electrons. And so it's going to be +2 and -2 for the oxygen. Okay? So and it's a donation. It donates. Now, if you are starting to recognize a pattern here, you're right. Ionic bonding, nonmetals with metals. 1 or more nonmetals and 1 or more metals combined together in an ionic bond. Okay? Does that make sense? So this is the first type of bonding that we're going to look at. Okay? Yeah, Tyler. Yeah. So the bonding between 2 nonmetals, we'll get to that. We'll study that pretty soon. Okay, that's called covalent bonding. But